In this video we're going to be finding averages from group frequency tables. Our starter is Demi rolled 2 dice and added the numbers she got each time. Put her results into the group frequency table below. I'd like you to try that and then find the mean, the median and the mode of the dice scores as well. So hopefully you had a go at those questions there. I'm going to give you the answers for each one. The dice scores, you just need to add them up. So this one was 6, so that goes in this score range here. So we're going to give that a tally of 1. So we've done that one. I'll go through the rest. So I've completed the frequency table. Just note that when you're doing a tally, it's like these. So you do 4 lines, and then for the 5th one, you do a diagonal line through them. So that's your tally, and then your frequency is just how many there are. So that one's 2, 7, and 2. 11 in total, and there are 11 results. Now we're going to find the mean, median, and mode of the dice scores. Well, the mode, let's start with that one. That's the most common. So the mode equals 7, because that's the number that comes up the most. Looking at this raw data here. So 7 comes up the most. For the mean, we need to add up all of the numbers and divide by the number of numbers. So for the mean, we need to add up all of these numbers: 6, 7, 12, 9, 4, 7, 8, 4, 5, 8, and 7. All of those. Put them all into the calculator, add them up, we get 77. But we need to divide it by 11, because that's how many numbers there are. So our mean is 77 divided by 11, which is 7. And then finally our median, that is all the numbers in order, put them in order, and then the middle number. So I'm going to rewrite all of these numbers in order. Now that I've written them in order, we need to find the middle number. So the middle number of this list, so I'm just going to cross off 1 from each end and keep going. So that's 1 off each end, next one, and so our median is our middle number, which is 7. So all of our answers, median, mean and mode, were all 7. But won't necessarily always all be the same. So in that example, we were finding the mean, the median and the mode from listed data, all of these numbers. We are able to put them into a group frequency table, but now we're going to go to an example where we don't have the raw data, we don't have the numbers, but we just have a table. And we're going to calculate the mean, median and mode in this example here. So firstly we'll start with the mean, and what we have in this table are sizes in millimeters of some leaf lengths. So what we know is that 36 of these leaves were between 50 and 53 millimeters. We don't know how big those leaves were. They could have been 51, 50.1, 53 millimeters, 52.8 millimeters, 51.5 millimeters. We don't know. So what we need to do is just take an estimate for what they could be, and the best estimate that you can give is the midpoint of the class group. So the midway point between those two. Now if you're not able to calculate it easily, to find the midpoint, all you need to do is add the two numbers together, end point, and then divide them by 2. And what you get is 51.5. So we're going to need to do that for all of the data. So I'm going to add in a couple more columns, because we'll need the midpoint, and then we'll also need to do something with the midpoint. So we'll do the same for the next class group. So we have 53 plus 56 divided by 2 gives us 54.5. Then the next one, 56 plus 59 divided by 2 gives us 57.5. And then finally 59 plus 62 divided by 2 gives us 60.5. So those are our midpoints. But what we need to do now is, given that we don't know the size of each one, we know there are 36 leaves that were in this group. We're saying that all of them were approximately 51.5. So what we need to do is, if there are 36 of them, we need to multiply each frequency with the midpoint. So we're going to do 36 times 51.5, 48 times 54.5, 28 times 57.5, and 8 times 60.5. And we're going to put them in this column here, and I'm going to call that M times F, midpoint times frequency. So I'm now going to calculate them. I'm going to do it on my calculator. So I've calculated all of those. That's just by multiplying each number. 36 times 51.5 gives us this. Those two gives us that. So just multiplying across. Then finally, we need to add up the total leaf length. So we're going to sum this column. So we're going to add all of these values together. And we also need to know the total frequency. So we're going to add all of these values together as well. So our two values are 6,564, and we're going to have to divide that by 120. So our final estimated mean value is going to be 6,564 divided by 120, which gives us a final mean average of 54.7. Now, this is called an estimated mean. The reason it's called an estimated mean is because we've done some estimating. We don't know how large each leaf was in each class group, so we've estimated the size of each one. So we've said that all of the ones in this first group were 51.5, so we've kind of used an average or a midpoint to help us estimate the mean. We're now going to find the class interval that contains the median. So we're not going to be able to find the exact median, but we will be able to find which one of these groups the median is in. Now the way that we do that is we use the frequency. There are 120 leaves in total, and remember we want the middle value. So the middle of 120 is, if we divide it by 2, 60. So we need to find the 60th value. So where does that 60th value fall? Well, there are 36 in the first group. Then in the next group there are 48. So if we add 36 and 48, we get 84. So the 84th one is in this group. So it means the 37th up to the 84th are in this group. So it must be this median group here. So we're going to write that whole class interval out. So it's 53 and 56. So there's our final interval that contains the median. The last one, the modal class interval, the way that we find the mode is by looking at which one has the highest frequency. So the group with the highest frequency is this group here. So that is our modal class. So again, we're going to write out this class, and that's our final answer for the modal class interval. What I'd like you to do now is find the modal class interval, an estimate for the mean, and the class interval that contains the median for each of the next 7 questions. So try the practice questions. Do as I've done on the example, and I'll give you the answers once you've done that. Okay, so here are the answers. we have 60 to 70 as the modal class, 63.5 as the estimated mean, and part C was the median, that's the median class interval. I'm going to show you the answers for each of the questions 1 to 7 so you can check your work. So those are the answers for question 2, and here are the answers for question 3. Moving on to question 4. So if you note that question 5 has 2 answers for the mode, that's because there are 2 most frequent class groups, and that's the same for question 7. So there are your answers for 6 and 7, but if you notice, there's 2 class groups because they both have the highest frequency. We're now going to look at some extension type questions. These are the questions that I'd like you to try. Firstly, interpreting data and then applying some of those skills. But we're going to use the example, and I've come up with 3 example questions. The first 2 are very much like those interpreting questions, and the last one is very much like the extension application type question. So for the first one, it asks us what fraction or percentage are 56 millimeters or less. Remember, these are leaves. So we have to work out the total number that are less than 56 millimeters. Well, this group are 50 to 53. These are 53 to 56. This is greater than 56 and less than or equal to 59, and that's 59 to 62. So we essentially want to find out what fraction these 2 groups are as a total out of the whole. So adding 36 and 48 together, and then we divide that by the total frequency. So if we add up all the frequencies together, we get 120 in total. So 36 plus 48 over 120, that's 84 over 120, and we can simplify that to become 7 over 10. And if you wanted it as a percentage, you just need to times it by 100, and that will give us 70%. Moving on to the second type, this asks us what fractional percentage are in the interval 50 to 59. Well, the ones between 50 and 59 are these 3 groups here, so we would need to add all 3 of those numbers together. If we add them together, we get 112, and again that's out of the total. There are 120 leaves, and if we want that as a percentage, we would times it by 100. But firstly, let's simplify it. We'll get 14 out of 15, and then if we times it by 100, our percentage will be 93.3 recurring percent. Finally, part 3, if there were 1,800 leaves on a tree, how many would you expect to be over 59 millimeters? So again, we need to use the fractions. So we need to find what fraction were over 59 millimeters. That's going to be just this group. That's 8 out of 120. And we need to know how many leaves would be over that. If there's 1,800 leaves, 8 out of 120 are over 59 millimeters. So if we multiply the fraction by the total number of leaves, it'll give us our expected value of leaves over 59 millimeters. And the answer that we get is 120 leaves would be over that amount. So now I'd like you to use those examples and then try both the application questions and the interpreting data questions. For each one, you're asked to look back at previous questions, to look at the frequency tables, and then you'll answer these questions. Pause the video, have a go at each of those questions, and then come back and look at the answers. Here are the answers for the interpreting. So you can check those. And then the extension questions below.